Hello everyone, my name is Supriya Bhosle, Assistant Professor, Computer Engineering Department from AISSMS, Institute of Information Technology. Today we learn about the concept related to the data structure and algorithm. Topic name is array versus linked list. For storing a similar data in memory, we can use either an array or linked list. Arrays are simple to understand and elements of an array are easily accessible. But array suffers from the following limitations. Array and linked list are used to store the similar data in a memory. The first limitation of array have a fixed dimension. Means once the size of an array is decided in a program, it cannot be increased or decreased during its execution. We'll take some example here. So the first, when we have to define the size of array, it's about 100. If you try to insert 101 element, so it's the crash. The crash is nothing but it does not allow you to store the next element in the array because the size of array is now exceed. So our program may crash. On other hand, if we use only the 10 elements, then the space for balance 90 element goes west here. So it's exceed and the wastage is happen because of fixed dimension of array size. So this is a big disadvantage and the limitation of array. The second disadvantage is array elements are always stored in continuous memory location. At time, it might so happen that enough continuous memory location might not be available for the array that we are trying to create, even though the total space requirement of the array can be met through a combination of non-continuous blocks of memory. We would still not be allowed to create the array here. So this is a second limitation of array. Next one is operation like insertion of new element in an array or deletion of an existing element from array are pretty tedious because during the insertion operation or deletion operation, each element after the specified position has to be shifted by one position. Suppose you are considering here the example of insertion. At that time, we have to use a right shift of an element and create a new position for the insertion. Same here, when we are doing a deletion, we have to use here the one position to left shift. So this happen or it takes the more tedious or pretty tedious operation is required when we are performing the insertion and deletion. It requires extra shifts left and right. It's depending on the operation. So the linked list is actually overcome all this disadvantage. That's why we are going with a linked list. A linked list can grow and shrink in size during its lifetime. In other words, there is no maximum size of linked list. The second advantage of linked list is that as nodes are stored at different memory locations, so it is hardly happen that we fall short of memory when required. And the third advantage is that unlike array, while inserting or deleting the node of linked list, shifting of nodes is not required. We are just using a dynamic memory allocation. When we are going to perform the insertion of new data in a linked list, we are just allocate the new node and that is attached with the linked list with the other node in a linked list. Same for delete. When we are deleting a specific node from the linked list, we just delocate the space and attach this pointer or shifting the pointer. So it does not require any kind of left and right shifting here. So this is about the difference between array and linked list. The first one is fixed size. As you know about, what is a big disadvantage of fixed size is resizing is very expensive, and there is a case of wastage of memory because of fixed size in an array. In linked list, we are going to use a dynamic size while we are creating a new node. Dynamically, it's created, allocate and deallocate memory space at a runtime. The next second point, in array, insertion and deletion are inefficient. Element are usually shifted. We are using a right shift and left shift when we are doing or performing the insertion and deletion operation in an array. But in a linked list, insertion and deletion are efficient. There is no any kind of requirement for the shifting. Third point, random access is allowed in array because array is always use indexing. So that is a efficient indexing used by the array. So the random access of element is allowed in array. But in a linked list, no random access because we have to follow a sequence here, and we have to uh, perform the operation sequentially only in sequential manner. It's not suitable for the operation requiring accessing element by index such as a sorting. Fourth point, no memory waste if the array is full or almost full. Otherwise may result in a much memory waste. In previous example, we seen that suppose we are defining an array of size 100 and we are only stored the 10 elements, so 90 element space is totally waste. So there, if you are using full of array size like 100 elements, we are storing, so there is no any kind of wastage is happen in array. But in a linked list, since the memory is allocated dynamically, so there is no any concept of wastage of memory. At a runtime, it is automatically created that node, so there is no any kind of wastage happen in a linked list. The next last point is a sequential access is a faster in array because the array uses a continuous memory allocation storage. Because the element is always stored in a continuous memory allocation space. When we are to fetching a first element, the next element is available or associated with the next position in a memory. But things is not done in a linked list. Sequential access is a slow because the nodes are linked with each other, but they are not going to use a continuous memory allocation for their storage. So sequential access is slow in a case of linked list, reason because the element is not in a continuous memory location. So this is about the difference between array and linked list. Thank you.